Welcome back to the fourth lesson on geometric optics, and in this lesson I would like to discuss the ray diagrams that we use as light moves from one optical medium into another, as well as Snell's law. So if we take that and we simplify it, we get n1 sine theta 1 equals n2 sine theta 2. Right, so the first calculation we need to do is light is refracted at the boundary between water and an unknown medium. If the angle of incidence is 25 degrees and the angle of refraction is 20.6 degrees, calculate the refractive index of the unknown medium and identify the medium. If you need to make a sketch, you can do a rough sketch here. Angle of incidence is 25. Angle of refraction is 20.6 degrees. So the light is going to slow down. So from medium 1 to medium 2, light is slowing down. So we write down Snell's law equation, n1 sine theta 1 equals n2 sine theta 2. N1 is water, 1.33 is the refractive index, sine of 25 degrees equals, we don't know what the second medium is, we need to calculate its refractive index, sine 20.6 degrees. So doing simple mathematics, to get n2 is 1.333 sine 25 divided by sine 20.6. And I would advise you not to do these calculations separately, but to substitute all the values into your calculator, because writing down rounded off values and doing the calculation for n2 with the rounded off values has a major effect on your final answer. So the answer I get is 0.60, and I can ignore the 1 after that. If we go back to that table in one of the previous videos, you will see that this is glass, because glass has a refractive index between 1.9 and 1.5, so most probably glass, this one. If you have to identify a medium like this, they will supply you with a table with different substances, refractive indices, so you don't have to worry about that. Right, so this second example, a light ray with an angle of incidence 35 degrees passes from water into air. Find the angle of refraction and discuss the meaning of your answer. So we need to use Snell's law. N1 sine theta 1 equals N2 sine theta 2. N1 is 1.333 sine of 35 degrees equals 1 sine I don't know what the angle of refraction is. To use mathematics to calculate the angle of refraction, we have to use the sine to the power -1 function, the inverse sine function, which will be inverse sine of 1.333 sine 35 degrees. Dividing by 1 will not change that number. And doing that calculation, sine to the power -1, open brackets on my calculator, 1.333 sine 35, and we get an answer of 49.869, which we can round to 49.87 degrees. Now, when the angle of refraction is greater than the angle of incidence, it means that light was bent away from the normal, and that means that light speeds up when it moves from the water into air. Right, ready for the third calculation. Light passes from water to diamond with an angle of incidence of 75 degrees. Calculate the angle of refraction and discuss the meaning of your answer. So from water into diamond, the light goes. So Snell's law equation, N1 sine theta 1 equals N2 sine theta 2. So the refractive index in water is 1.333. The angle of incidence is 75 degrees. So we get the refractive index of diamond is 2.419, and they want us to calculate theta 2. To calculate theta 2, we need to use the inverse sine function, and 1.333 sine 75 degrees, divide that by 2.419, the refractive index of diamond. Don't do these calculations individual step by individual step and use rounded values, because that affects your final answer. So inverse sine of 1.333 times sine 75 divided by 2.419, and the answer I get is 32.159, so I'm going to write 16 degrees down. So what is the significance of this answer? If the angle of refraction is smaller than the angle of incidence, the light is bent towards the normal, and that implies that the light slows down when it moves from water into diamond. Right, there is reference to another video that you might want to watch if you Google it. I don't know if you will be able to see clearly there. Right, thank you for joining this lesson.